Hey everybody, welcome to today's virtual video lesson. All right, so we talked about the process of memory briefly yesterday. So the memory process is complex. It happens in 3 stages and it involves different types of memory. The first is encoding, the second is long-term memory, and the third is recall. There's another type of memory system that works with the others. It's called working memory. This system holds information in mind for a very short amount of time so the brain can either use it right away or store it. So encoding is the transforming of internal thoughts and external events, like song lyrics, into short-term and long-term memory. This is the process in which information is processed and categorized for storage and retrieval. It is a crucial first step in creating new memories. The second step is more like a long-term storage unit. It stores 2 kinds of memories. Episodic memory, and this type of memory is all about important personal events and feelings connected to them. Think about your last family event. You probably remember who was there, what you talked about, and the food you ate. The second type of memory is semantic memory. This long-term storage unit also holds all of those facts you can recall when asked, such as when did Christopher Columbus sail to America? This is the kind of general fact that is stored here and is the main type of memory used for storing school-related learning. Recall. This memory system finds information that is in storage and retrieves it. Think about Christopher Columbus question. If 1492 doesn't pop into your mind in a second or two, you'll use other strategies to find it. You might recite song lyrics from grade school with the Ocean Blue lyrics. Recall system taps into our higher order thinking skills to find information. These skills let us organize what we want to know about a topic. Check and form associations such as Grandma's house is where you first tried caramel corn. Hold and compare information such as the weather that day was unusually cold. Then we went into testing our memory. We did a quick video that challenged us to test our memory. So this is just a fun little memory test. It has absolutely nothing to do with intelligence, just kind of memory. I'm going to be on my first time doing it this morning. I got only 4 out of 7, but by the end of the day, since I had done it 6 times, I got 7. Just kind of a fun way to look at your working memory, how much you can recall in a short amount of time. We're going to turn it over to Hank for a little bit, and then we're going to do a
then stored for future
optical illusion using your eyes.
use, then eventually retrieved. Sounds simple, but by now you've figured out that just because you take a lot of stuff about your mind for granted doesn't mean that it is not complicated. By Atkinson and Schifrin's model, we first record things we want to remember as an immediate but fleeting sensory memory. Think back to the image I showed you a minute ago. You remember his name? If you do, it's because you successfully managed to shuffle it into your short-term memory, where you probably encoded it through rehearsal. This is how you briefly remember something like a password or phone number. Like, hey Tommy, what's Jenny's number? Okay, 867-5309. 867-5309. 867-5309. You're getting it in your head there. Or in this case, I told you to remember that guy's name. Maybe you were thinking Leonidas repeatedly over and over, even if you didn't think you were doing it. But this information really only stays in your short-term memory for under 30 seconds without a lot of rehearsal. So if you weren't repeating Leonidas, you probably have forgotten it already. Because your mind, amazing as it is, can really only hold between 4 and 7 distinct bits of information at a time, at which point the memory either decays or it gets transferred into long-term memory. Long-term memory is your brain's durable and ridiculously spacious storage unit holding all of your knowledge, skills, and experiences. Now, since the days of Atkinson and Schifrin, psychologists have recognized that the classical definition of short-term memory didn't really capture all of the processes involved in the transfer of information to your long-term memory. I mean, it's more than being able to just remember some Greek guy's name. So later generations of psychologists revisited the whole idea of short-term memory and updated it to the more comprehensive concept of working memory. Working memory involves all the ways that we take short-term information and stash it in our long-term stores. And increasingly, we think of it as involving both explicit and implicit processes. When we store information consciously and actively, that's an explicit process. We make the most of this aspect of working memory when we study, for instance, so that we can know that Athens is the capital of Greece and that Pompeii was a Roman town and not a Greek one. This is how we capture facts and knowledge that we think we're going to need. Like I told you, specifically to remember Leonidas' name, you concentrated on that detail and filed it away, if briefly. But of course, we're not conscious of every tiny thing that we take in, yet our working memory often transfers stuff we're not aware of to long-term storage. We call that an implicit process, the kind you don't have to actively concentrate on. A good example might be classically conditioned associations, like if you get all sweaty and nervous at the dentist because you had a root canal last year. You don't need to pull up that file on the last time you got your face drilled on to think, well, oral surgery, not my favorite. Instead, implicit processes cover all that stuff automatically. This kind of automatic processing is hard to shut off. Unless you got something unusual going on in your brain, you might not have much choice but to learn this way, like how you learned how to not put your hand into a fire. That learning would have happened pretty much automatically as soon as you first yanked your hand away from an open flame. Whether those things are lodged in there explicitly or implicitly or both, there are also different kinds of long-term memory. For instance, procedural memory refers to how we remember to do things like riding a bike or reading. It's effortful to learn at first, but eventually you can do it without thinking about it. Long-term memory can also be episodic, tied to specific episodes of your life. Like remember that time that Bernice fell out of her chair at chemistry and everybody started laughing uncontrollably? Good times. There are other types of long-term memory too, and we're continually learning more about the biology and psychology of the whole complex phenomenon. For instance, while Clive Waring's episodic memories, among others, seem to be deeply affected, his procedural memories for things seem to be in one piece. This has to do with neuroanatomy that we do not have time to explore here and that we don't yet fully understand. Waring and others have a lot to teach us about the different types of long-term memory storage. Now, for healthy memories, there are lots of little tricks you can use to help remember information. Mnemonics, for one, help with memorization, and I'm sure you know a few that take the form of acronyms. Roy G. Biv for the colors of the rainbow, for instance. Mnemonics work in part by organizing items into familiar, manageable units in a process called chunking. For example, it may be hard to recall a 7-digit number, but it'll be easier to commit to memory in the rhythm of a phone number, 867-5309, or you could just write a song about it. Strategies like mnemonics and chunking can help you with explicit processes, but how well you retain your data can depend on how deep you dig through the different levels of processing. Shallow.
All right, we're going to stop it there. And then the last thing we looked at was an optical illusion because we talked about the brain and people were curious about the eyes. So within your eyes, you have rods and cones, and they are very small. The rods are in charge of seeing the black to white color spectrum, so everything in the middle. And the cones are in charge of seeing colors. And each cone is responsible for seeing one of 3 different colors, red, blue, and green. So we're going to look at this optical illusion. That's going to change. That's going to change from a black and white picture to some color, and then they're going to have an after image. It's due to color saturation. It's a pretty cool thing.
Of optical illusions by Crazy Videos.
So we're going to stare at the center dot.
Center of the screen. Keep watching the black and white image of the castle. Keep watching it. It'll soon change to a sort of colour image. You've got to keep watching that dot in the middle of the screen. There
Keep
comes
watching.
the colour image. Keep watching that dot in the middle of the screen. Shortly you'll be presented with the black and white image again, but you'll see it in colour. Weird effect, isn't it? It's coming any minute now. Keep watching the dot in the centre of the screen. Do you see the colour image? Glance away and it reverts to black and white. Hope you enjoyed this illusion. Bye for now.
Exactly. A lot of people think that I'm trying to trick them, but as you can see, we can go back in the video and watch it change. If you're not looking at the dot, you can clearly see it's going to go from our yellow and blue just to black and white. So no trickery there. Just due to color saturation in your eyes. All right. Have a wonderful day and wonderful weekend. I will see some of you on Monday and some of you on Tuesday. Bye.